I am be doing number 18, and it asks to solve the system of DEs, and we're given this problem. So I'm gonna go ahead and put it into this form and put it into a matrix, and from here on I'm gonna find the eigenvalues and then the eigenvectors given those eigenvalues. So I'm gonna go ahead and do the standard of finding the eigenvalues. I'm going to take the determinant of this. I'm going to get my eigenvalues, and I'm going to have to plug this into my quadratic formula because that's not factorable, and I get my eigenvalue as 5 and -1. Moving forward, so my eigenvectors of this form, I go ahead and plug in my first eigenvalue that I found, which is -5, into my matrix for the eigenvalue, and the bottom rows will always cancel out. I'll reduce this, and then I'll go ahead and put it into this form. Have it the x and y, go ahead and multiply it, and then we can see that x is equal to y. So I'm gonna let y equal to 1, and that's my first eigenvector. Alright, then for my eigenvalue would be -1. I'll do the same process. I'll put -1 in here, and the two negatives will create a positive. This once again will cross out, equal to 0. This will be reduced to 1 and 2, as you can see here. I'm gonna plug it into the formula once again, multiply by the x and y, and it turns out that my x is equal to -2y. I'm gonna let my y equal to -1, and that's my second eigenvector. Alright, so I'm gonna use the formulas that are in the book, and as we can see here, that y bar prime is equal to the inverse of a as y bar. As you can see, this is equivalent to this, which if you take the derivative, not the derivative, the integral of this, we get our integrating factor, and this is our eigenvalues, 5 and the -1. And these are the 3 different ways how to represent it: a matrix, vector, and I forgot the other one, but yeah. So here's one way, and second way, and third way. Also, since there are 2 vectors, eigenvalues, it's non-defective because our matrix was a 2 by 2, and since there are different eigenvalues, it's also linearly independent.